join people. I think we'll get started, okay? So hey everyone, my name is Viren Varma and welcome to the introductory session on Kaggle by IEEE and CIS, the Computer Intelligence Society. My name is Viren Varma. I'm the ex RAS chair. I was the RAS chair last year from 2022 to 2023. A little bit about me. So I was a mechanical engineering major with an IT minor. I interned at Wells Fargo as a data analyst intern, where I got my PPO and I'll mostly probably be joining. I'm a GSOCer. I cracked GSOC this year at Faro Consortium. I did a research internship at IIT Kanpur back in the beginning of my third year. I published a research paper in CentCon as the ML lead in a robotics paper, and yeah, I was also the intelligence co-chair at Web Club. So that's me. Coming to the main part, so what exactly is Kaggle? So Kaggle is basically a platform run by Google, which is for data scientists and machine learning enthusiasts, and it's a public platform. Anybody can go and register on it, and they can participate into hackathons. They can learn from courses. They can already see pre-built data pipelines and models that other people have built for similar problem statements, and then learn from it. So that's how that's done. I'll be sharing this entire PPT link as well very soon. Oh yeah, I forgot to do slideshow. Sorry. Okay, so why to appear for hackathons? So definitely money is one reason. In general the prize money for hackathons are pretty high. They're also very competitive. So some of the on an average hackathons give about 10 to 20k dollars if you come in like the first or the top three, and that's divided between the top three. But there are several hackathons that give like about 100k as well. And not just hackathons, Kaggle does a lot of other things as well. Right now they had the reproducibility challenge, which I'll get into in the later parts of what that is, but that's also one of the advantages over there. Coming to again, the hackathons are not just concentrated to Kaggle. There are like several other places where you can appear for hackathons as well. That being Hacker Earth, Machine Hack, Data Hack, the Smart India Hackathon, which is a very popular platform for several hackathons. So that's also a very good option. There's also eYantra, which is sort of a robotics hackathon by IIT Bombay, but that's a whole different thing. Not very similar to Kaggle, but yeah, it's also one of the hackathons. Standard IDs that we're going to be using today, we're going to be using Collaboratory, which is this one over here. But there's also a separate functionality by Kaggle, which is the Kaggle Notebook. So, okay, how many of you over here have like a basic idea of what Kaggle is? Have at least like seen one of the data sets or one of the competitions in Kaggle? So I have a base idea. You guys can just raise your hands or like unmute yourself and talk. It's okay. Okay, I see Abhay Bhandarkar and Aryan Kashyap. Abhay, you can. Okay, so I think a decent people of you have basic idea of what Kaggle is, right? 6 more have you. Okay, great job. So yeah, so that's basically the Kaggle notebook where you can like where you can basically where you can go into a competition and straight away start programming from there. You can lower your hands, okay guys. And straight away we can import your libraries and then import the data set, split it into train and test, and then start coding out the entire data pipeline to make the predictions. You can also download the entire download the entire data set, go into Anaconda, and then access the data from there. All these concepts we'll be doing later on, and trust me, we're going to be doing a code along as well. So don't worry if you don't get it right now, if you're a little bit on the newer side. Coming to Anaconda and Jupyter Notebook. So yeah, so as I said, Anaconda is basically an ID in itself, and yeah, Anaconda is basically that's a navigator and has like several other IDs in itself. One of them being Jupyter Notebook, which is very convenient to use. Jupyter Notebook is basically a web-based ID, an integrated development environment. So once you have the entire Anaconda set up, you can create a new environment over there, and you can have all your packages that are very specific to a particular prompt statement or your ML this thing. and you can have it over there, and you can open that particular environment in your Jupyter notebook, and from there you can run like separate IPYNB files. One disadvantage for that is you'll have to use a graphic processor, a GPU from your PC. So if your PC does not have a very good GPU, that might not work, because or even if it does, setting up a GPU is usually yeah, as I said over here, a really big pain. So that's usually not a very reliable way, but definitely if you have like a really good GPU and a really good GPU access, this could be a very good option for you to run the model faster. So GPUs can be used where you have like very heavy data or very large amount of data in terms of file size, which can be like images or audio or other signals. So that kind of data requires GPUs like these. If you guys like from third year or second year and you need like IT or IT minor or computer science background, you might have learned GPUs in your parallel computing course or your computer architecture course. So that's basically that. Coming to the next part, yeah, if you want to set up Anaconda and if you want to go through that route while competing in Kaggle, that's the entire link for it and how to go forward with it. We're not going to go too much into this because that's not how, that's not how I operate. I don't usually use Anaconda that much unless it's a separate data set, unless I really need the code to run locally and not on the server. So moving forward is collaboratory, Google Colab, and mounting the drive. So yeah, Google gives a pre-built GPU which is already in access. Here's my camera. Sorry. Yeah, which it gives inside the collaboratory. So that's, yeah, it's a small meme for that. And yeah, Kaggle API. So coming to what Kaggle API is, so basically if you go into like your profile and you go into settings, I'll just go over here. This is a new profile that I created. So if this is assuming a new profile that you have in Kaggle, so you can just go over here, you can go over here, you can go to your profile. Once you're in your profile, you can go to the account section. Over here, if you just like scroll down, if you guys want, you can like code along with me. If you guys like fall behind a little bit, you can just let me know. Okay, I'll just run a sample code here for you. You can like create a new API token over here, and that will like save a JSON file into your PC. And what you can do after that is how to connect to the Kaggle API is, I'll show you in a minute. So assuming if this is a particular competition that you want to participate in, this is a particular competition you want to participate in, and you've already downloaded the JSON file for the Kaggle API. What you need to do is, you need to mount your drive first. So that's basically these are the two lines of code that you need to use to mount your drive. Another thing that you can do is you can go over here. It's unmount drive right now because I've already mounted my drive. So you can unmount your drive and then do this. So what I'll do is I'll unmount my drive. Actually, I'll reset the entire runtime. I'll do it with you guys. So what you can do is you can run these two lines of code and you can mount your Google Drive, so which is your so now the drive has been mounted, and over here inside my drive, you can see your entire Google Drive that's there. That's my drive. So that's that. Inside that, if I run ls again, as you might have seen in command line in Linux, if you do ls, you can see which files are there in the particular directory you're in right now. This works very similar to that. If you use like an exclamation mark, you can do similar things over here, and you can cd into drives. So if you want to like install a particular package, you can just do an exclamation point and install the package over here. So if I do ls, I can see which files are there. So right now I'm in drive and sample data. So at the moment I am here according to my Kaggle notebook. And yeah, I installed the package, which you can do anywhere. It's going to get installed in the particular environment, like it works, and it's only going to be installed in the runtime at the moment. So I'll just do that quickly until we go to the next stage. And yeah, you can again, now what we're going to do is, now this is a very optional thing that I do, but it cleans up the code pretty well. So I'm going to cd into a particular folder that I created. So I created this folder called CIS hackathon session. That's inside my drive. So once you're inside your my drive, and I'll just show you over here, you need to upload the Kaggle JSON file. Now right now I already have uploaded it. You can use these two lines of code to upload it, or you can just like manually right click and upload it. That's all the same. It won't make much of a difference. What you have to do next is you have to create a Kaggle directory inside it, and you have to copy your Kaggle JSON into that, and that's that. So right now it's going to give, yeah, it won't make another Kaggle directory. We've already run this code previously, and once that is done, yeah, you can see the Kaggle dataset list over here. So these are all the datasets that are there on Kaggle, the title, the reference, size, and everything. Now I want the house price advanced regression technique. Now where did I get this from? You can just get it from, one second. Over here. So that you can just copy it over here, and you can paste it, and it'll get, and all the data will be downloaded right now, and it'll download. Okay, I'll just download the data. Downloaded. Now again, okay, so house pricing data comes over here. So the one, yeah, again, so the advantage of me first cding into this particular folder was that I once I hit the download button, it's going to download inside this directory. The data won't go anywhere else. So that's one advantage. Now I can access the data over here. That's the data. So once that has been done, again, yeah, then you can run this entire file. So again, from there I'll have to extract it over here and put all the data here. Now I did it for another repository earlier, so I'm just going to use that, but because it's a little bit of a lengthy process, it takes like a few minutes, which we don't have right now. So again, we'll just do a quick thing where I'll cd into another. Now again, all this that I'm doing right now, you don't have to do that. You just have to extract this, keep all the train test files over here, and then run the code further. But sec. Over here, I already have a train.csv. Great. Okay, now I import all my files. I set a train, and I get the train.head. Okay, now from here you can start like building your entire data pipeline. I won't go into what all you can do over here, just because there's a lot of stuff that you can do over here. But I'll definitely be sharing this particular IPNB file because it has most of the things that you can do. You can see the train.info, and you can see all the info related to each and every attribute that's there inside the data, and how many, yeah, if it has a null count, how many null counts it does have, its D type, and all of that. Are you guys following up till now? I'll just stop here if there's any doubts. If you have any doubts, just raise your hand or something. All good, all clear up to this point? Okay, I'll take the silence as a yes. I'll move ahead. Yeah, one second, sorry, there's a message on the chat. Yeah, absolutely. Yeah, actually, I planned for a video demonstration. That's why I did all this. But yeah, absolutely, it's all being streamed on YouTube. It's all being streamed on YouTube, and I'll be sharing this IPNL file as well. It's just due to time constraints, I just move forward with it. But yeah, we could have done a code along as well. Okay, coming to how you can process this. The first is oh yeah, sure, absolutely. These are the first two lines of the code. That's the mounting of the drive right here. Okay, someone sent a YouTube link. I'm not sure if I should press that. Okay, so I'll just move forward right now. Any more questions? Well, that's all. Okay, that's all. Thank you. Okay, yeah, moving forward, yeah, I'll just explain a few basic parts of any simple data pipeline. So there's a few things that you'll have to do in the beginning. So first, yeah, first you need to start with analyzing the data and how the attributes are labeled. How many of them are numerical data types? How many of them are categorical data types? What their D type, what their nature is, and what their D type is. And if you don't want to process a particular object in terms of an object, you can always convert it to a string, and it'll still be a categorical data type. But that's that. Sometimes categorical data types are given as integer labels, so you can change them to categorical data types. That's something you can do even before running a model. That's the pre-processing, which is like the most important part of any data pipeline. I mean, that is the entire data pipeline. That's the most important part if you want to, like, if you want good predictions or good results. So moving forward, yeah, over here I can see which are the unique, as in right now it's house pricing data, right? So according to say the lot area, the lot frontage, and year it was built in, according to this, how we predict how much the sale price is going to be for a particular area. So over here we can see the unique ones for these things. So these are the only three ones which have null values. So over here I've identified that wherever there's a null value, I'm going to replace it with a mean for lot frontage. For MAS VNR area, I'm going to replace it with again the mean value. And for garage year built, as in the year which it was built in, I'm going to use the mode value. So mean and mode we usually use to replace null values in cases of numeric data types, and mode is something we use in terms of categorical data types, so where we cannot use mean. So, and in general, even if a categorical over here, like for example a year is given, so year may be an integer data type or a D type, but it is a categorical variable. So that's that. So yeah, again I used mode for that. Once that was done, I filled it with the particular, as I said, what I'm going to do. I created a correlation matrix just to see how the entire data is correlated, and I dropped ID and sale price. Sale price something we're predicting, so it doesn't have to be in train. It has to be in the Y. X train does not need to have the sale price and the ID, because ID is not something that's going to affect the sale price. As you can see over here, ID is going to have very low correlation with everything in the yellows mostly. So in general, there's like very less correlation. There's a couple of attributes that have like decent correlation, and then it's going to be the diagonal that has one. So for very obvious reasons. So once that's done, you can like create a histogram to see how the entire data is distributed, and if there's a particular, and if there's like some, what do we say, anomalies or outliers that are there in one corner, you can just remove them to make the data more even or to smooth the data out. There's several other packages you can use for smoothing as well, but we'll come to that later. I can't run each sell at the moment because a little short on time. But let's see. If there's time in the end after questions, we can go through the entire IPNY file separately. So over here, I've given you a couple of packages that you can use for any Kaggle competition to, to which is SQL pipeline, how to a simple imputer, column transformers, one-hot encoders, and standard scalars. So one-hot encoder is something you can use for your categorical data. So a string or an object might not be very readable for the model, so you'll have to one-hot encode it. Or there's also this one. There's also label encoder as well. So what one-hot encoder does is it creates an array with whichever class the particular label belongs to, it one hot encodes it, and that's how it's passed. Whereas label encoder is something that's, I'll just add label encoder here. A label encoder is something that labels it in terms of 1, 2, 3, and several others. So again, yeah, later on when you're gonna be having the IEEE hackathon, please do use all these packages for running your models. If it's a regression problem statement, if it's a what do you say, classification problem statement, quite similar packages can be used for that. In terms of ML models, I think in terms of a random forest regressor, you can just use a random forest classifier, and if you fine tune it, you can get like very good results just using that. There's also XGBoost that's going to be very useful for hackathons, and not just in Kaggle but any hackathon, because XGB is like one of the top models, and most of the time the winning algorithms are either XGB or a fine-tuned version of XGB, or say an ensembled version of XGB. Now, what an ensemble model is and why you need to do ensembling in any hackathon is very important, and I'll get to that later on. But yeah, breaking the entire data into test and train, and then training it on your fitting it on your test, fitting it on your train, and then seeing the test as well, and then seeing all the what do you say the results in your test as well, the resulting parameters. This is a regression problem statement, so we're going to be seeing R2 score and MSE. So I'll just quickly go to that. That's the test log, and that's the submission over here. Let me show you 1 second. So right here the score over here that's written over here, that's the R2 score. So R2 score is basically the square of the coefficient of determinants, and that's over here. If you want to like understand what an R2 score is in layman terms, it's basically how similar the particular patterns are for the predicted graph as well as the original prediction of y and the predicted graph. So over here we have an 83% similarity, which is what the R2 score says over here. And then there is MSE, which needs to be as low as possible, which is just the mean square error. I think it's pretty simple to understand. And once you've done the entire prediction, you need to create the submission file using this, and it needs to correlate with the ID, and that's the sale price, and then you need to save it as a submission file inside your this thing. So over here, initially when I did this, sorry, I think my PC hanged a little bit. Yeah. So initially, when I CD'd into my house pricing folder, what simple thing it does is whenever I'm saving it, whenever I'm saving a particular CSV file in it, I don't have to define a particular path over here. It automatically saves inside the particular folder, and I can just go there, download it, and upload it in Kaggle. And that's that. This entire procedure, if you just like if you don't want to use Colab and you don't want to go through the entire hassle of a Kaggle API, you can just leave out all this part. You can just start from this point, and I'll add a text over here. Start from this point for Kaggle notebook. So later on, when you're in the hackathon for IEEE, as Inba said, it's I think on the 21st, right, Inba?
No, it's in the next weekend.
Okay, so
19th.
19, thank you. Sorry. So it's on the 19th. So when you're going to be doing that, you can just, if you're using the Kaggle notebook, you can just start from here. Or even if you're using like Anaconda ID, you can again start from here. You can download the data, and then from there, again, once you've set up the Anaconda ID and the Jupyter notebook, you can again you just import the packages, copy the path over here, get the, what do we say, the data frame, load the data frame, and then start programming from right here. So the pipeline is going to be very similar. Uh, okay, so moving ahead. Yeah, so again, cross validation. I think you guys are familiar with what cross validation is, right? I don't need to explain that. I'll go to the chat again. One sec. Okay, I'll take the silence as a yes. So yeah, basically, yeah. Once you have like cross validation, you've set up the k-fold cross validation, and it's showing like good results for each and every fold in your private, in your what do you say, notebook. But whenever you upload it in Kaggle, it shows like very abysmal MSE, which is mean square error, or like really bad. I think for Kaggle, for regression problem statements, usually MSE would seen, and you need to reduce the mean square error as much as possible. And yeah, they can use R2 as well, but in general they use MSE most of the time. For classification, it's mainly the this thing. What do we say? If it's an anomaly detection problem statement, it's mostly going to be recall. Otherwise, it's mainly the F1 score, if I'm not wrong, which they check in general. F1 score is basically 2 multiplied by precision into recall divided by precision plus recall. If you want to know what that is in classification, there's a whole other lecture I can take on ML where we can see that. But coming to the Kaggle notebook, in general, Kaggle notebook is something that's that's used most of the time. I in general prefer Google Colab with API because I've had a much better experience with it. But definitely, Kaggle notebook is also a very good option, and also without a doubt the most widely used option. Again, small meme here for that. You can also use Python on terminal, which is maybe as painful as it can get, but yeah, that's also one of the options, not gonna lie. Types of problem statements. So coming to types of problem statements on Kaggle and oh shit, sorry, sorry, I accidentally pressed control. Types of problem statements on Kaggle. So there's definitely image classification. But what they can ask you to do is they can give you an image, and they're gonna ask you which of the objects are there in it, or which of the entities are there in it. So there's a cat here, there's a cat and a duck here, there's a cat and duck and several. There's a dog as well, but that's that. So what you can do is you can segment the particular image. You can use either Haar cascades to decide what is there in it. You can train a CNN and then see what the image is initially showing, and then use a Haar cascade and decide it. You can use capsule networks for it. So that's one of the sections of problem statement that can go in it. There's also time series problem statement. Time series problem statements are basically where the data is time dependent, and or where the data is sequential, you can say, where the data changes with respect to time, and you need to keep in mind what the previous value of the data for a previous time statement's value was to predict what's going to come for future time steps. So that's a time series problem statement. Then there is anomaly detection, which is again one of my favorites because most people don't understand anomaly detection and the advantage of a class imbalance. I'll get into this more later on, but anomaly detection is mainly like fraud detection or cancer detection. Like if you have like considering I worked when I interned at Wells Fargo, they gave me an anomaly detection problem statement to solve for my 2 months of internship. So basically, they had like they had about I think 1 lakh data points of customer acquisition, in which they acquired like really small businesses, and where 1% of those businesses were frauds, and they wanted to see how we could have previously predicted using machine learning if that particular business is gonna be if that particular business could have been at least at least we could have set a red flag over there, or at least we could have put it in fraud review, so that that 1% fraud that we're getting in the final output is reduced. So that is something that I used batch-wise ensemble technique, and that's how I predicted the entire. That's how I solved that problem statement. But there are several other ways you can solve this as well. What you can do is you can set like very specific class weights in the model for each and every class, and assuming we have like a 0 and a 1, so, and we have about 1,000 data points, so and only like 100 of them are from class 1 and the rest 900 are from class 0. So naturally the entire model is going to be inclined a lot towards 0. So what we can do in class weights is, if we predict a 0 correctly, the let's say the reward value for that's going to be zero point 0.1, whereas if we predict a class of 1 correctly, the reward value for that is going to be zero point 0.9. So we're significantly increasing the correct prediction of class 1, the weight of that by a lot, and that's how the model is going to be inclined more towards detecting class 1. Because otherwise the entire 1,000 data points, you can just predict everything as 0, and we'll still have a 90% accuracy, because 900 data points of those 1,000 data points were actually 0. So that's what an anomaly detection prompt statement goes as. There's also natural language processing, again a very very Kaggle favorite line of prompt statements. So over here they have like, assuming you have like comments and stuff, you have natural language that people usually write in like comments, what we use to communicate with each other as well. So how to process this, how to create a bag of words, there's like a whole separate set of models for this that you can search for. There's also forecasting problems which are very similar to regression problem statements. So regression algorithms do work very well with forecast problem statements as well. There's also a lot other lines that I've not mentioned over here, which are signal processing, audio processing, and that stuff, but that are in general rare on Kaggle. And these are mainly the 5 very very common types of prompt statement that I have encountered. So yeah, that's that. Moving forward. Okay, is everything clear? I mean, this is a very very sorry. This is a very very important slide. So is everything clear over here? Do you have any doubts regarding? If you want anything to be explained again, anything to be written down for you, I'll do it right now. Just ask me. I'll wait for like a minute or so.
Time series part, can you tell again?
Yeah, sure, absolutely. Sorry, that's my fault actually. I'm keeping my phone on control. Yeah, so time series part is basically time dependent data, where in the training set you're gonna have one of the attributes as time, and there's gonna be other attributes that are gonna be dependent on that time. They can have a positive or a negative relation with it, or an exponential relation with it, but they are going to be very well related to that time. So, or it can be, yeah, time series is very, you can use sequential models also for it. So that's what a time series data is, and there are several separate algorithms which are there, like LSTM and other time series data models. Even XGBoost and random forest work very well with time series data problems if they're tuned very finely. So that's one of the set of time series. You have a specific question on time series that you want to ask, or does that solve? Does that answer your question?
This is fine. Yes.
Okay, okay, no problem. Anything else that needs to be explained again? No. Do you have any questions regarding this? Okay, I'll recommend you guys stay in the chat, because later on I'm going to be sharing these links in the chat as well, so you can just copy them and keep them with you. Because yeah, I mean there's no way I can find a group with everyone that's in it, so there's no group like that I can share all these links to. But yeah, okay, I'll move forward then. Yeah, again, the standard packages that are there, NumPy is again a package for math mainly, and how you can convert it into a particular NumPy array to make the computations a little bit easier. Then there's Pandas, which is a very good package for loading the data frames and everything and doing all the computations on the data frame. converting it from a CSV to a data frame. This is the package you use. Keras and TensorFlow are two of the machine learning packages. TensorFlow is mainly for low level APIs, and Keras is mainly for high level APIs that are there. You can build like your separate, you can build a neural network or a convolutional neural network using these two packages by adding convolution and dense layers to it. And yeah, you can just use a dense model as well. For that, the last time in my third year, I think there was a in my second year, there was a hackathon by Web Club, and over there was a neural network that actually won the particular hackathon, and not any fine-tuned or pre-run model. So I'll recommend you testing out neural networks as well for your hackathon in Kaggle. That's there next week. SQL Learn is again one of the most, if not, I mean, if not the most important algorithm, one of the most important libraries that are there. It can give you like several packages for pre-processing as well ML algorithms, as well as the what do we say to classifying results, all the R2 packages, the MSE packages. If it's a classification problem statement, this is where you extract your what do we say, the classification matrix or the confusion matrix package from. So you can just run the package and you can put your uh, y y test and your y prediction, and it'll give you the entire confusion matrix or your classification matrix. So SQL Learn it even has data sets and everything. So this is like one of the most important packages that you'll need for your hackathon. That's that. Seaborn is again one of the libraries we use for visualization, apart from Matplotlib. So all the histograms that you saw over there, all the graphs that you'll see in the IPONB file that I shaved, IPONB file that I shaved, are usually made using these particular packages. So that's over here. Yeah. I already explained this part. I actually went there earlier, so I think this slide is a little redundant. So yeah, coming to data pipeline. So what a data pipeline is? So a data pipeline is a series of data processing steps where each step delivers an output that acts as an input for the next step. So as you can see, initially we had the link or the path for our training CSV. So using that, we extracted the data frame. This particular data frame was uh, then used in the next cell to split our X train and Y train from, and then that output was then used to break it into our test and our training and our validation sets, and so on and so forth. Different steps are run. So that's the entire data pipeline. And yeah, creating a data pipeline is one of the most important parts in any hackathon. If you, for people who are like very regular in hackathons, they just have like one standard data pipeline and they do like minor tweaks to it, and they appear for several other hackathons. So if you have like one very solid and very standard data pipeline, you can pretty much crack any problem statement there is out there. Yeah, again, there's a little meme over there. Yeah, ML is actually not the hardest part, because technically they're not letting you. ML is basically, I mean, the machine learning aspect of it is pretty less over here, because they're not letting you touch the insides of the algorithm. What you can do is you can just, uh, pre-process the data as well as you can, and you can find out the model that works as best as as it works the best, and you can just use that model with the right kind of, say, hyperparameters, which you can find using grid search, and that's how you can do it. So yeah, ML is actually pretty less over here because they don't let you touch the insides of the model and how it works. But yeah, so in general, in most applications, data pipeline is the most important part there is. I'm already on the 45-minute mark, so I'll just move a little forward. Coming up with an efficient data pipeline. So here are the steps for coming up with a very efficient data pipeline. The first part is the feature engineering. So in feature engineering, all your setting the proper input values for your null values, removing properly, what do we say, reducing the number of dimensions, the proper dimensional reductionality, removing all the useless attributes from the input, uh, removing, I mean, smoothing out the data, that all comes under feature engineering. And this is, again, as I said, the most important part of any data pipeline. Then comes the ML algorithm. You can use lazy predict to find out which ML algorithm works best for it, and then use a grid search algorithm to find out which hyperparameter is best for it. So that's how you can very well run the machine learning algorithm. Ensembling. If you remember earlier, I said ensembling is one of the most important parts in any particular hackathon. And I can assure you 95% of the people will not do ensemble when they're appearing for a hackathon. But what you need to do is you need to run separate ML models and test out their accuracy. And in the end, what you can do for a regression problem statement, you can take the average of them all. So for each and every solution, for each and every y predicted inside the testing, you can average out all the results that you got for it, and then you can put that over there. And if it's a classification problem, and if it's been classified into a particular class, you can vote it out, and whatever the maximum class that you're getting with each and every model, you can put that in your final model. So that's how you ensemble the results, and I can assure you you'll get one of the best what do we say accuracies if you ensemble the results at the end. It can backfire as well if you use, like, if even one of the models in the regression problem statements has a very high MSE, it can very well backfire. But in a lot of the cases, ensembling the results only enhances the prediction and doesn't what do you say reduce it. And then there's the validation framework. Now validation framework is seeing how well the results add up to. So why validation is important, I'll just explain to you. So basically, assuming if we're, say, predicting how many people are going to get cancer, and a hospital needs a program for that, and assuming it had a test pool of about 1 lakh people, there's like 1 lakh people out there which are tested on, and a hospital is say claiming that it has a model where it can predict if a person has cancer with an accuracy of 99.9%. So is that considered to be right? I mean, yeah, it can be right, and statistically they might be very correct, because getting cancer is like a 0.1% chance, and even lesser for any person. So if they just predict that nobody's gonna get cancer out of the 1 lakh people, for 99.9% of the people they are gonna be right. For, like, yeah, 99,900 people, they are gonna be correct for that, and the rest 100 people, and they're not going to be correct for. So what the validation framework does is it sees which of the resultant parameters that we need to see properly. So for this particular cancer problem statement, it's not the accuracy that we need to see, it's the recall that we need to see, or the capture rate that we need to see. If you have like a basic idea of what classification is, you'll understand this part. If not, just let me know. I'll explain what a recall is or what precision is. No, are you sure you have a, I mean, all of you have a pretty decent idea of what classification is, right? I'll take that as a yes. Okay. Okay, we're already at the 49-minute mark. So yeah, feature engineering has these 4 parts that I'm going to go into. Again, so data preprocessing is data integration, collecting the data from all the database and cloud. Over here, you won't need to do the data integration part, because Kaggle is already going to give you the data. Then we come to data cleaning first, which is dealing with all the null values, empty columns, and correcting data formats. So if a particular column has like 90% of the column is just null values, you can just drop the entire column. You don't need to fill it and impute it with a mean or a mode value. So just drop that particular part. Then comes data reduction or dimensional reductionality, which is basically removing the useless rows which are not going to affect the particular prediction, or the useless columns that are not going to affect the prediction that much. Oh, thank you so much, Adil. Your nice diagram for explaining precision recall. Coming to data transformation, again, data transformation for like, yeah, assuming if the data values for numeric values are very very huge in thousands or 10,000s or lakhs, and if they need to be converted in a scale from -1 to 1, you can use a transformation for that. And if, yeah, obviously one hot encoders and label encoders are also a way to transform categorical or string or say object data type into numeric data types and then run in the model. Coming to the machine learning algorithms that we can use for that. So nice meme for that. People are saying AI is going to take over the world, and yeah, there. I mean, I once had a CNN that predicted a fly as a cat. So yeah, they, if not predicted correctly, these things happen. Yeah, these are the machine. This is again a cheat sheet that I found on the net that you can use for the particular prompt statements that I said earlier. So unsupervised learning, which is if you don't have a label defined, and you need to basically just cluster the particular data points. There is k-means, k-mode, Gaussian mixture model, hierarchy of models that you can use for that. For unsupervised learning for dimensional reductionality, I think principal component analysis is one of the most popular, but single value decomposition and latent, I can't pronounce this word, but I call it LDA. You can use LDA as well. But yeah, principal component analysis is something that's the most popular and the most used. You can also use p values, and then according to those particular p values, you can reduce the dimensions as well. Coming to the supervised learning part, which is just divided into classification and regression. So for regression, you have gradient boosting, which is gradient boosting random forest, which is again a version of a boosting network, and decision tree networks, linear regression that you can use for a regression prompt statement. Earlier, when I showed you the IPONB file, we used random forest over there and XGB, which is, yeah, again a gradient boosting algorithm. For classification, there's several actually. There's linear support vector machines, there's naive bias, there's decision trees, logical regression, which is for like binary classification, kernel SVM, random forest, and XGB, again common classification as well, and again are one of the most popular algorithms. So in general, if it's like a very complex data, I'll highly recommend you to fine tune a random forest or an XGB network, and that's definitely going to give you one of the best results. Model validation has already been covered earlier, so that I don't need to. So yeah, again, one of the advantages of this hackathon is going to be working with your peers and networking very well. So yeah, that's one of the advantages over here. A small meme for that. And yeah, there's several levels of Kaggle. So after the IEEE hackathon that's done, you can like go into these. So when you start out, you're a novice. As you can see, when I created a new account over there, and when I used the Kaggle API, I was a novice over there. But later on, as you add more comments to other competitions, as you make more submits to other competitions and get a decent rank in them, you can rise in the rankings to from novice to contributor to expert to master to grandmaster. There's only been like 4 or 5 people who've reached the level of grandmaster in Kaggle, so that's like very very prestigious. But yeah, definitely, it's a very very prestigious thing to have. And there's a small meme for it over here if you're in for the prize. Yeah, that's it. I think we finished just right 5 minutes before the deadline. So yeah, that's that. We have another 5 minutes for all the questions. I'll just come back over here. Yeah, do you guys have any questions? I'll just stop presenting the screen. I'll share this thing as well. I'll share all the links as well over here in the chat box. You can just raise your hand and unmute yourself. It's very chill. No worry.
Hello.
Yeah, yeah.
Yeah,
Hi.
if there are any questions, thank you, Viren, for the wonderful and informative session. Hope everyone enjoyed this introductory session on Kaggle. I'm Mohammad Adil Shabir, a second year computer science and engineering student at NITK, and I'm the CIS secretary at IEEE. So this event is a great opportunity for all of the first and second year students to enhance their machine learning skills and dive deeper into this exciting field. As a platform for data science competitions, Kaggle has become increasingly important in the industry, and it can be a great asset for anyone looking to build a career in machine learning. As you know, we have an exciting practice contest lined up from today until the end of the week. And the next weekend, that is from 19th to 21st, we'll be hosting the Kaggle Cup, a 48-hour hackathon with a total cash prize of 4.5 thousand Indian rupees, along with exciting prizes and goodies for the next top three teams.
So yeah, hello everyone. I'm Radhika, and I will quickly go through the practice contest once. Just a second. So yeah, this contest is for helping you to getting started with the Kaggle. So yeah, the problem statement for this contest is to classify the mobile phone on the basis of the price range, given the features of the mobile phone. So we have four categories. First is zero, which means low cost phones, then one, medium cost, second, two, high cost, and third, which is very high cost. So you don't have to predict the actual price of the mobile phone, whether you have to tell which categories the phone falls according to the features given. So this is the problem statement, which is a multi-class classification problem according to the types of problem wherein explained. So yeah, here we are sharing some resources which will help you to get started with the machine learning. And here is one reference notebook. If you are using Kaggle notebook for your submission, you can check this out. So yeah, this is the description of the contest. It is open now, and it is open till May 14th. And we are using F1 score as the evaluation metrics. The submission file should be of this format: ID and predicted, where ID is the ID as specified in the test file, and predicted is the predicted label of the mobile phone class. So yeah, I can share the data. Oh wait, I have to you have to join the competition, agree to the rules, and then yeah, there are two data files. One is train.csv and another is test.csv. Uh, all columns are explained here. So if you have any doubt, you can check from here. In train file, you will see the, wait a second. So in the train file, you will see the price range labels, but in the test file, you have to predict it and finally submit the ID and that predicted label. I will go through the notebook once. Okay. Uh, just a second. I'll show that later. Firstly, yeah, there is a leaderboard which will show your ranking, and you can code your Kaggle notebook from here. Like you can make a new notebook, or you can use Collab as Viren explained. Now I'll show the baseline notebook which is there.